Okay, let's do some proving here. This is going to be probably a little sloppy because I'm totally winging this. Okay, now we got this isosceles triangle with AC and AB being the same length. We're trying to prove that these two medians, so BD and CE, are congruent. They're the same length. So let's see. I think the way I'll go about this is there's these two triangles down here, right? We got DCB and ECB, and we're going to prove that they are congruent. And if they're congruent, then BD and EC have to also be congruent because they're corresponding parts of congruent triangles. Okay, so let's see. I'll start out with AC being congruent to AB. And also, oh yeah, that's given, right? Definition of isosceles triangle. And then, well, if those are congruent, then DC, let's see here, DC, I'm trying to figure out how I want to say this. I mean, basically, DC is going to be the same as EB because they're both half of AC. So let's do this. Let's go CD equals 1/2 AC, and then we'll say that EB equals 1/2 of AB. Okay, and that's just definition of shoot, I should have thought this through a little bit better. Midpoint, but we don't know that that's a midpoint yet. So actually, we need to say that D is midpoint. Oh, this thing's a mess. Pause. Okay, so I kind of did this out of order, so we're gonna just cross all this off. Okay. And we're going to say that D is the midpoint of AC and E is the midpoint of AB. How do we know that? Well, because that's the definition of median. Right? We're told that CE is a median, so that's what a median does. It stretches from a vertex to the midpoint, so that must be a midpoint. And therefore, CD is 1/2 of AC and EB is 1/2 of AB. Okay? And therefore, and that is just definition of midpoint. That's what a midpoint is. Okay? I mean, I suppose you could drag this out a little bit, but essentially, this distance is half the whole distance. That's what a midpoint does, right? Cuts it in half. So now, but we know that AC and AB are the same. So really, right, CD is equal to 1/2 of AB, and that's just substitution, right? So I just replaced AC with AB, that's all we did. How do we know we do that? Well, because AC and AB are the same. Now, technically, I should have gone in and said that AC equals AB, right? So I could add this in here a little bit. I would say that AC equals AB, and my reason for knowing that is definition of congruent. So earlier we established that they were congruent, and that means that they are the same. That they're the same length, and therefore the AB and AC are the same number numerically, they're the same length. So I can replace AC with AB. Okay. So now I put these two together. If EB is 1/2 of AB and CD is 1/2 of AB, then I can just replace and let's say that EB equals CD. Okay. EB equals CD. Now, we get in a little bit of a fuzzy territory about how we know this. A lot of people will put transitive property. Okay, and that is technically a little iffy here, and we don't want to take too much time bothering with what transitive property or substitution. Substitution just means you can replace one thing with another. Transitive property means that if A is the same length as B and B is the same length as C, that A and C are the same length. And that'll often be used a little incorrectly, but I'm not going to worry too much about that. Okay? And therefore, if EB is equal to CD, then segment EB must be congruent to segment CD. And that is definition of congruent again, right? That's what it means to be congruent. So let's go back. We now know that this segment here is congruent to this segment here. Okay, so let's see. Next, we've got that CB is congruent to itself. Okay. So we've got CB congruent to CB. And anytime you're saying that two things are, or something is the same as itself, you're using reflexive property. Right? Reflexive property. All right. So CB is the same as itself. So now what we have to do is prove that these two angles are the same. And actually, we know that down here, we'll just say that angle DCB is congruent to angle EBC. Those are those two angles in the corner. And I'm just going to say base angles of isosceles triangle. That's not like we'd have to prove that to be true. And we could prove that in a separate proof, but typically that's something you prove early on, so we're just gonna accept it as true. All right, so now we know that these two triangles, DCB and EBC, they share a pair of congruent angles. On either side of that pair of congruent angles, they have this side here, and then they have these two sides over here. So E to B and B to C are the same as D to C and C to B, with the same angle in between those two sides, which means that we have side angle side congruence. So we have that triangle DCB is congruent to triangle EBC. That's those two triangles down the bottom, and that's by side angle side. And make sure, of course, that you name these in the correct order. DCB, down 3 across the shared side, down 3 across the shared side. When I say down 3, I mean the ones I labeled as 3 tick marks. So make sure you name them both in the same order. And of course, now that we know that they are congruent, we know that CE and DB must also be congruent. So I would say CE congruent to DB. And that is by corresponding parts of congruent triangles are congruent. So quick review. Okay, we know that the two big sides are congruent. That's a given. We know that D and E are midpoints of their respective sides because that's what a median does. Okay? We know that the two short segments, DC and EB, that they are both half of their respective longer sides because that's what a midpoint does. We know that AC is the same as AB. So AC, AB, we know that they're the same length because that's what it means to be congruent. We previously said that they were congruent, which means they're the same length, which means that in this equation, this is an equation, I can replace AC up here with AB. So now I have that CD, instead of being equal to 1/2 of AC, is equal to 1/2 of AB. And then, if that's true, well, then EB is equal to 1/2 AB, CD is equal to 1/2 AB. If EB and CD are both equal to the same thing, then they're equal to each other, which means that they're congruent. And if they're congruent, and we also know that that bottom side is congruent to itself because they both share that side, reflexive property, we know the two angles are congruent because they're base angles of an isosceles triangle, and therefore the two triangles are congruent by side angle side, and which means that those two medians, which are corresponding parts of the two triangles, must also be congruent. And we're done.